Hi everyone, nice to meet you again. And now we continue with uh, water supply engineering subject with the module of water distribution system. And then in the lecture 3, we are going to explain on water reticulation system. So similar to the previous lecture, yeah, uh, in this water reticulation system, it also based on Hazen-Williams equation. Yeah. So previously we have introduced this equation. Yeah. For instance, for the head loss HL here, this one equal to length multiplied by Q and then divided by 0.85 A surface area times CH times R power 0.63. And then outside the bracket there we have the power 1.852. So the explanation on this symbol, yeah, HL is head loss in meter, and then length is also in meter, and Q flow rate in cubic meter per second, and then diameter is also in meter. So if CH is Hazen-Williams coefficient without dimension or dimensionless. Yeah. So if this Hazen-Williams equation, now we modify. Yeah. Uh, okay, now A actually is the surface area of the pipe. So this surface area actually 1 over 4 multiplied by pi and then time diameter square. And then R actually is the hydraulic radius. So this hydraulic radius is perpendicular divided by surface area. Yeah, so this one is surface area divided by uh, wet perimeter. Yeah, wet perimeter. So R is equal to 1 over 2 times D. And then Q, if we convert it from 1 cubic meter per second to the liter per second, become 1,000. Yeah. So similarly to diameter, if in 1 meter we convert to millimeter, become 1,000 millimeter. So the Hazen-Williams equation then we can express, yeah, as HL equal to 1.225 multiplied by 10 power 10 divided by D power 4.87 multiplied by L, yeah, and then multiplied by Q over CH power 1.85. Yeah. So this one is based on the conversion factor, yeah, that we already explained previously. So this one is explanation on heat loss, length of pipe, flow rate, diameter, and also Hazen-Williams coefficient. Yeah. All right. Now let's say this equation, yeah, this top equation, we assume like HL equal to one constant R multiplied by Q power M. Yeah. So in this regard, Q power M is Q power 1.85. Yeah. So we can definitely determine M is equal to 1.85. However, for R, this one is a bit complicated. Yeah. In which R equal to 1.225 multiplied by 10 power 10 divided by D power 4.87 and then uh, multiple by L multiple by 1 over CH power 1.85. Yeah. So these are actually is this, yeah, 12.25 multiplied by 10 power 9 divided by D power 4.87 and then multiplied by L divided by CH power 1.852. And then m is a q power m, in which m is 1.85. So basically, the method, to determine the head loss and then the diameter and also the flow rate, in the reticulation system is a bit complicated compared to the single pipe, because this one is interconnected. So we have to do some assumption, and then we do trial and error. So one of the method to determine the head loss, the diameter, and the flow rate inside the water reticulation system is Hardy cross method. So based on this method, uh, two basic hydraulic conditions for pipe must be met. The first one, the sigma q, meaning that the total flow inside the pipe, by considering that what to say, the flow of the clockwise is positive, and then the flow of anti-clockwise is negative, should be zero. Delta Q should be zero. And then for the pressure continuity, the second assumption, the sum of head loss should be also zero, by considering that the flow that follow the clockwise is positive and anti-clockwise is negative. So in this regard, sigma head loss equal to zero in equation 2. So based on this assumption, the procedure, to design the calculation in the reticulation pipe using the Hardy cross method are as follows. The procedure a bit long maybe, but the procedure we should put flow rate assumption to all pipe in the system. So this one is purely our assumption based on the logical consideration. And then we calculate the head loss. We calculate the head loss uh, for each pipe by using the equation of HA equal to this one, R power QA, R multiplied by QA power M. So then, assuming that M is 1.85, and then divide the pipe network into a number of closed loop by having enough number to ensure that each pipe is included into each loop. The sentence quite difficult to understand, but let's see the example later on. And then the step 4 is estimate the sum of the head loss, in the each loop. Okay. Then the next step is to calculate the value of sigma HLA over QA, and then estimate the correction of delta Q. Then using this formula to determine the delta Q, and then we do correction with the flow rate, in which Q equal to QA plus delta Q. And then repeat the above procedure until we get the accuracy required and until delta Q is very small or close to zero. So for this explanation, I would like to show one example, to make it easy to understand, because if we follow the procedure, it look like hard to understand. Okay, so for instance, we have here the pipe loop like this. So this is the pipe loop like this. The inflow is from here. The flow rate of inflow is 110. liter per second. Yeah. And then we have also the outflow here 35 lps, here 35 lps, and here is 40 lps. Yeah. And then also given here the information of the length of the pipe here is 800 meter with the diameter is 10 inch. And here also we have different information for length and diameter. Yeah. Here also we have information of length and diameter. Yeah. So here also we have. So the first step to solve or to determine the flow rate inside the pipe, yeah, we apply this equation, yeah, Hazen-Williams equation to determine the head loss, and then similar to the previous one, yeah, by assumption that the uh, Hazen-Williams coefficient is 100. Okay, this is the flow rate of water. So the first step, yeah, we should take any value. Yeah, let's say here we have the flow rate is 110. So here now we assume here is 50, just for the first assumption. Yeah, and here is of course this one is 110 minus 50. Yeah, so this one is 60 here. Yeah. So if we see in the step by step calculation, yeah, here we have 50 lps. So that's why we obtain here 60 lps. Yeah. So here 60, here is 50. Because here is 60, and the water withdraw here is 40, so we left here 20. Yeah, automatically 20. 20 is 60 minus 40. Okay, so that's why here we have the flow rate here is 20 lps. Yeah. And similarly for this one, actually this one is 50 minus 35. Yeah, so we obtain this 15 lps value. At the end, here we obtain 35 lps as the sum of this one and this one. Yeah, this one 20 and this one is 15. So that one is the first assumption. Yeah, the first assumption. So the first step, yeah, we list out the length and the diameter. Because all of this we should apply it in Hazen-Williams formula. So in Hazen-Williams formula we found this factor, yeah, d power 4.87. Yeah, so d here is in millimeter. So after we do the power of 4.87, we obtain this value respectively. Yeah. Similarly to 1 over c power 1.85, this one also similarly, c value is 100, so 1 over 100 power 1.85. So we obtain this value. And then R actually is what to say, according to Hazen-Williams formula. So this one all calculate, yeah, all calculate, yeah, and list out in the table. And then this R value, yeah, we put it here. Then we do listing again for 5AB, 5BC, CD, and AD, and we list out the R value based on the calculation here. And then for the Q1 is 50, and then this one is in AB, yeah, our assumption, and we assume also for AD, yeah, AD 60, and this one is based on calculation. Yeah. So for the sign, yeah, for the sign, if the flow is like this, so we assume the sign here is positive. Yeah, this one also positive, and this one negative, and this one negative. Yeah, so that's why here AB positive, BC positive, but CD and AD is negative here. Okay. So similarly, in calculation of head loss, also we do the assumption of positive and negative. Finally, we obtain HL over Q, and then after we determine by formula, delta Q, we obtain delta Q equal to 2.75. So because of the delta Q is 2.75, so here we have to add on here, because positive, uh, 50 plus 2.75 become 52.75. This one is 17.75, but this one should be subtract. 20 subtract 2.75 become 17.25. And similarly to this 16, subtract by 2.75, we will obtain 57.25. So uh, after having this this calculation, then we obtain delta Q 2.7. So each of Q value should be corrected by this delta Q. So here previously 50 become 52.75. This one 15 becomes 17.75, and this one uh, previously 20 becomes 17.25. And similarly to this one. After the second iteration, we obtain the HLA, and we obtain the value of zero. Value of zero, similarly to HL over Q become zero, so the iteration should be stopped. It means that the flow rate that we determine is already corrected. So no need more correction. So I think that's all for the presentation. Thank you again for your participation in this class. So now I will stop